Hello, this is the luckiest maths teacher in the world, and today we're beginning our journey on equations. So the first thing I want you to be able to do is to understand and define what an equation and solution actually means. Okay, let's go through it. So, an equation is a mathematical statement saying that two things are equal or the same. So if you'd like to pause the video and take down this definition, be my guest, but it's on the sheets that I've given you. So the dead giveaway of an equation is an equal sign. So something like this is an equation. It has an equal sign. It's a statement. Now for our purpose, a statement is just something, information, that can be true or false. So the Broncos will win next year's NRL Premiership. That's a statement. Mr. Luck is the luckiest maths teacher in the world. That is a statement. It can be true or false. And just like the statement that I put up here, it can be true or false. In this case, it's true. 2 does equal 1 plus 1. Okay? Another statement I could make, an equation, could be 4 plus 5 equals 10. Okay? Now that is a statement and it is an equation, but of course it is not true. It's an untrue statement. So I could make many untrue statements, like AFL is better than rugby league. That would be an untrue statement. Saying that Macklemore isn't the best rapper, that would be an untrue statement. So I'm going to show you how to make true statements. So I've just put up another equation. Now this looks slightly different because, despite my terrible handwriting, this has a letter in it, so it's not all numbers. So the statement is x plus 8 equals 12. Now sometimes that's true, sometimes it's not true. That depends on the value of x. So remember, as we learned when we did the algebra section of this course, that x can be any number. Now, when you're given equations like this one, the one I've just given you, you'll be told to solve those equations, which means find a solution. A solution of an equation is a number that I can substitute for the pronumeral, i.e. the letter. We did all this in algebra. So that I can substitute for the letter to make the statement true. Okay? So let's just look at this. So if I change x to 5, or I substitute x for 5, let's see what happens. I can cross out the x. I get 5 plus 8. Sorry about my writing. I'll do that again. I get 5 plus 8 equals 12. Now that is an untrue statement because 5 plus 8 is actually not the same as 12. But if I change it to 4, if I change x to 4 instead, then the statement will become true. So if I change it to 4 plus 8 equals 12, this is now a true statement. As true as the fact that Mr. Luck is the luckiest maths teacher in the world. So I have a true statement. So what that means is that x equals 4 is a solution to the equation x plus 8 equals 12. So this statement, this equation is true when x equals 4. It's true when and only when it's x equals 4. If x equals something different, it's not a true statement. This equation has one and only one solution. There are no other solutions. There are no other numbers I can substitute for x that will make the statement true. Now, I just want to let you know that at this point, we haven't actually done any solving of equations. So all I want you to know is that x equals 4 is a solution because it makes the statement true. At this point, you don't need to know how I got the answer x equals 4. Most of you can probably guess that intuitively, but you don't need to know how to solve them yet. I just want you to understand and be able to define what an equation is and what a solution is. Alright, so let's just do another quick example. Okay, so is a equals 7 a solution to the equation 2a minus 5 equals 22? So to check if something's a solution, all we need to do is substitute it into the equation. So this is the equation. The giveaway is the equal sign. So that's how I know that this is an equation. If I change a to 7, I get 2, 7 minus 5 equals 22. But the astute of you will remember that if I have 2a and a equals 7, 2a doesn't equal 27. Because 2a means 2 times a. It doesn't mean 2 is the first digit and a is the second digit. So this is actually 2 times 7 minus 5 equals 22. Now 2 times 7 is 14, minus 5 is 9. 9 clearly doesn't equal 22. So the answer is a big no. A equals 7 is not a solution to this equation because it does not make the statement true. Okay. Now I'm going to go to the next part. So if you need to copy this down, please pause the video. Okay, so you're in luck with this next part because we already did this in the algebra section of the course. We already practiced taking a whole bunch of words, a bunch of information, and writing equations from it. So I'm just going to go through this quickly. I'll go through an example. Okay, so let's say I'm given this information and I have to write an equation. So a taxi charges $5 per kilometre and a $12 call-out fee. Remember, we went through this. This just means that they charge $12 to come and pick you up, and then they charge you $5 per kilometre. So if the fare, the total journey costs $67, I want to write this as an equation. So again, as I did in the algebra section of the course, we just take all the information and replace it with numbers and mathematical symbols. So a taxi charges $5 per kilometre and a $12 call-out fee. So it doesn't matter that this was a taxi. Could have been a ferry or whatever. So we don't actually need to include that in our equation. Maths people are very succinct. That means they use as few words as possible. So we get rid of all the information that we don't need. So I'm going to write this as an equation. So the taxi went for X kilometres, $5 per kilometre. So think about the operation that's used. So $5 for X kilometres, or 5 lots of X, is multiplication. And we don't have to write the multiplication. So 5x is how we can write $5 for X kilometres. But he also charged an additional $12. So he charged the 5x plus $12, and the total was 67. So this equation here in red represents all this information just in a much more succinct way. This is an equation because it has an equal sign. Now, most of you probably can figure out what x is. You can probably figure out how many kilometers this person traveled for. However, we're not up to solving yet. If you can do it, that's fantastic, but don't worry if you can't. All you need to be able to do is write equations from words. So again, take the information and just write the same information with mathematical symbols, getting rid of anything that doesn't matter. Okay? So, I'm not going to go through that again since we did it heaps in the algebra section of the course, but if this doesn't make sense to you, this particular example, please let me know. Because now we're going to move on to the next part, so again, pause the video if you'd like to copy this down. Okay, so the last thing I want you to be able to do today is understand what equivalent equations are. Equivalent, similar to equal, means the same. So we're looking at equations not that are exactly the same, but that give the exact same information. Now, when I write an equation, so let's write an easy one. 3 plus 2 equals 5. I have a LHS, which means left-hand side, and a right-hand side, okay? Similar to when we had fractions. I know this probably sounds a bit abstract, but when we had something like 3/4, remember, to make an equivalent fraction, we could do anything we wanted to the top as long as we did the same to the bottom. So I could times the top by 10 as long as I times the bottom by 10 as well. So 3/4, 3/4, is clearly the same as 30/40. It's a similar idea here. What we do to one side of the equation, we have to do to the other side of the equation. What we do to one side of the equation, we have to do to the other side of the equation. What we do to one side of the equation, we have to do to the other side of the equation. No, your YouTube isn't breaking down. I just really want you to understand that. Whatever we do to one side of the equation, we must do to the other side. We can do anything we want to the left-hand side as long as we also do it to the right-hand side. So let's look at the equation here. that I wrote before. So 3 plus 2 equals 5. Clearly that's a true statement. If I add another 2 to this left-hand side, it's not true anymore. 3 plus 2 doesn't equal 5. It equals 7. But if I also add 2 to the other side, this is now true again. 3 plus 2, which is 7, does in fact equal 5 plus 2. So this is awesome. This is a true statement, because 7 does equal 7. Now it's exactly the same when we have letters. So let's say I told you that x plus 1 equals 4. Okay? Now what I can do is I can do anything I want to both sides of the equation. So if I choose to add a 3 to this side of the equation, I must add a 3 to that side of the equation. So now, if x plus 1 equals 4, x plus 1 plus 3, so that's x plus 4, must equal 4 plus 3, which is 7. What that means is that, I'll write the first one again, x plus 1 equals 4 and x plus 4 equals 7. They are equivalent equations. Okay? I'm going to come up with another one. I can actually times both sides of the equation by whatever I want. So I'm going to take this equation and times each side by 2. Now, if I times the left-hand side by 2, because there is more than one term there, I must times everything by 2. So that's why I put the brackets around it. So remember the distributive law, we go 2 times x, 2 times 1, put the plus in the middle, and then on the other side we just have 4 times 2, which is 8. So these are all equivalent equations. So what that means is x plus 4 equals 7, x plus 1 equals 4, and 2x plus 2 equals 8. They are all equivalent equations. They all give the same information. And it turns out, as we will see later, they all have the same solution. Okay? So let's start with something like x equals 3. Times each side by 2, I get 2x equals 6. They are equivalent equations. I can do whatever I want. I can subtract 5 from each side, and they're still equivalent. All of these have the same solution, x equals 3. That's why they're equivalent equations. Now, they're different in that there are different numbers in each of them, but they all give the same information. Just like this over here. Gives the exact same information. 3 plus 2 equals 5. 3 plus 2 plus 2 equals 7. Same information. Okay? So, I hope you now understand what equations and solutions are. You've had a good revision about how to write number sentences into equations, and you understand the concept of equivalent equations. Any of that doesn't make sense, come and see me. Otherwise, have a wonderful day. This has been the luckiest maths teacher in the world.